see these symbols? You're solving an inequality. It's very similar to equations, but there are some important differences. Here's our first problem. 17x is less than 51. Let's solve for x. Just like in an equation, you notice that there's multiplication, so use division to undo that. That reduces, I get x, keep the less than sign. 51 divided by 17 is 3. So the answer is x is less than 3. Now I want you to graph the solution so we can understand what this means. This is very different than x equals 3, which would be one single solution. This does not include x is equal to 3. It's everything less than 3. That's an infinite number of solutions, but there's also a lot of numbers that are not true for this statement. So let's draw a picture. I like to put that number right in the middle instead of putting a whole bunch of numbers on the number line. How does x relate to 3? It doesn't equal 3, so I'm going to draw a hollow circle around the 3, meaning do not include 3. Less than 3 is where all the values of x are, everything less than 3. You've got whole numbers like 2 and 1 and 0 and -1, but you also have all the rational numbers in between, like 2.9999999 is included. So the way we show that is with shading. We start at our circle and just shade in the less than direction. And that's one way to show your graph. That is a picture of all the values less than 3. Let's try the next example. Over here, I'm going to write a new rule for you that is incredibly important. If you multiply or divide by a negative, you must flip the inequality. Let's see how that relates to our current example. So I have x times -17. I'm going to divide by the exact same number on both sides. So I'm dividing by a negative. This reduces, but I have to flip the inequality. That means instead of less than, now it's greater than. 51 divided by -17 is -3. And that's the solution. X is all the values greater than -3. So let's draw it. Here's my -3. X can't be equal to -3, so I draw a hollow circle around it. And I'm going to draw my shaded area a slightly different way. It's just a different style that is also very common. If x is greater, what you can do is go straight up and draw an arrow above the number line. Instead of shading, you can show it this way. They mean the same thing, and it doesn't matter at all to me which way you do it. X is greater than -3 does not include -3. There's a picture of it. So this rule is really important. This is the big difference between solving equalities and inequalities. If you multiply or divide by a negative, flip that inequality every time. Here's another example. Let's start solving it the way we would if that was an equal sign. We subtract 25 from both sides, right? I'm left with -4x greater than 42. Now to get x by itself, I need to divide by -4 on both sides. So x is what? Well, I just divided by a negative again, so I must flip it to less than. This does not go in evenly, but you can reduce. So it could turn into 21/2. And you could also rewrite that with a mixed number so that we can visualize this better, -10.5. So if we're going to draw a picture of that, you can actually just put -10.5. If you want to, you can anchor it with some integers, which is a really good idea. Think about what two integers this is between. Here's -10. And here's -11, and it's halfway between those two amounts, right? Now, x is all the values less than -10.5, so we draw an open circle, and we shade everything to the left. I'd like to change this problem to greater than or equal to, so you can see what happens with that. In fractions where the numerator or denominator is something a little more complicated, you need to picture parentheses around it. We call these implied parentheses. Every fraction has them, and in the order of operations, you would need to simplify that before you do the division across the bar. But we're not going to need to do that in this problem. Okay, I'm going to get rid of divide by -5 by multiplying by -5. And since I'm multiplying by a negative number, I need to flip that inequality. These reduce, and I'm left with 12x minus 7. I don't need the parentheses anymore. I flip the inequality the other way and finish my multiplication. So I have 10 over 11. All right, keep going. Add 7 to both sides. So I have 12x is less than or equal to, and this is just 7 and 10/11. Next, I'm going to divide by 12, which is the same as multiplying by 1 over 12. But this cannot be a mixed number. You need to change it to an improper fraction. So let's simplify a little bit. That reduces. I have x, and that was positive number, so this does not change. 87/11 times 1/12. 87 over 132. Okay, that's our solution. Now let's see what the graph is going to look like. 87 132. Well, the or equal to is what's new here, and I want to show you what to do. You put a solid dot instead of a hollow dot because we do include this number in our solution. X can be that or anything less than that. And so you can shade to the left to show the rest of the solution. So there's an introduction to solving inequalities. Remember the rule about multiplying or dividing by negatives, and you should have no trouble with this. So go do some.